Ever wonder what's really happening behind the scenes when an app just blows up overnight? Or when you're binge watching your favorite show with millions of other people? Well, it's not magic, it's some seriously incredible engineering. Today, we're going to break down that powerful infrastructure that runs the world's biggest apps, and we're going to see how you go from just one single server to a massive global fleet. Okay, just picture this. You've built an amazing app. You launch it, and boom. Overnight, it goes viral. Millions of people are signing up. I mean, that's the dream, right? Well, for your server, it's pretty much a nightmare. What do you think happens when that one little machine you started with suddenly has to handle the traffic of an entire city? You see, most applications start out their life like this, as a monolith. Just think of it as one big, all-in-one unit. Your user login, your payment system, your newsfeed, everything is all tangled up together in one giant piece of code. Now, it's simple, and it's definitely straightforward to get started, but yeah, there's a really big but coming. Right, so when that viral traffic hits, the monolith just starts to fall apart. The server gets totally overwhelmed, and it just crashes. And what's worse, all the different parts are so tightly connected that a single bug in some minor feature, like, I don't know, the profile picture uploader, it can crash the entire app. And updates? They're a nightmare. You have to redeploy the whole thing just for a tiny change, and you're just hoping you don't break everything in the process. So pretty clearly, that all-in-one approach just isn't built for a massive audience. It's brittle, it's fragile, and it just can't grow. We need a totally different way of thinking about this, a whole new architecture that's designed for massive scale and reliability right from the very beginning. And this is the big shift in thinking. We're moving away from the monolith on the left, that one giant block, over to a microservices architecture on the right. The whole idea is to stop building one huge application and instead build a whole bunch of small, specialized services that just talk to each other. So here's the key takeaway with microservices. You break your app apart. You have one service just for user accounts, another one just for payments, and maybe another for recommendations. Each service does one thing, and it does that one thing really well. And, critically, each one can be updated, deployed, and scaled all by itself, without touching anything else. This analogy just nails it. A monolith is like a Swiss Army knife. All the tools are stuck together. You know, if the screwdriver part breaks, the whole thing is kind of useless. Microservices, on the other hand, they're like a toolbox. You've got a separate hammer, a wrench, a screwdriver. If one tool breaks, you just replace that one tool, and the rest of the toolbox is totally fine. And this, right here, is why all the biggest apps use this approach. Is your video streaming service getting slammed with traffic? No problem. You just add more power to that one service. The recommendation engine goes down? Who cares? Users can still log in and watch their stuff. And your payments team wants to ship a new feature? They can do it anytime they want without waiting for anyone else. This is how you get both speed and stability. Okay, so this sounds amazing, right? We've solved our big scaling problem, but we've kind of created a new one, complexity. Instead of managing one application, now we might have dozens or even hundreds of them. How in the world do you make sure they all play nicely together, especially when they all need different settings and libraries to run? Well, the answer is this amazing piece of tech called a container. A container is like a perfect little self-contained bubble for your code. It packages up a single microservice with literally everything it needs to run. The code, all its special libraries, all the settings. It's all in there, completely isolated from everything else. And that brings us to another perfect analogy. The most popular container tool, Docker, is basically the standardized shipping container for the software world. I mean, think about it. Before shipping containers, moving stuff around was chaos. Afterwards, you could use the same cranes and ships to move anything, from cars to bananas. Docker does the exact same thing for code. It puts your service in a standard box that can run anywhere. Your laptop, a friend's laptop, a giant cloud server, it doesn't matter. And the process is actually really simple. First, you write a plain text file called a Docker file, which just has some simple instructions. Then, use that to build something called an image, which is like a blueprint. And from that one blueprint, you can launch as many identical running containers as you want. So we've packaged up all of our services. Our app is growing like crazy. But now, we don't just have dozens of services, we've got thousands, maybe tens of thousands of these containers running to handle all the users. We are at a totally new level of scale. So how on earth do you manage all of that?
How do you keep track of thousands of moving parts, make sure they're all healthy, and that you have exactly the right number running at any given second? You need a conductor for this massive, sprawling orchestra. And that conductor is Kubernetes. Kubernetes is what we call an orchestration platform. Its job is to automate the incredibly complex task of deploying, scaling, and managing this whole fleet of containerized applications. It's the brains of the entire operation. Let's stick with this orchestra analogy, because it's perfect. The containers are all the individual musicians, right? Each playing their part. Well, Kubernetes is the conductor, telling the violins to play a bit louder when needed, bringing in the drums at just the right moment, and making sure that if one musician stumbles, the whole symphony just keeps on playing beautifully. So, what does this conductor actually do? Well, it's pretty magical. If one of your containers crashes, Kubernetes just automatically replaces it. That's self-healing. If traffic suddenly spikes, it'll automatically add more containers to handle the load. That's auto-scaling. It even handles all the complex networking, so all the services can find each other. But maybe the most powerful idea is that it's declarative. You don't tell it how to do things. You just tell it the state you want. Hey, I need 5 web servers and 10 database connections. And Kubernetes works 24/7 to make sure that's exactly what you have. So there you have it. This is the modern stack that basically powers the internet as we know it today. You start with a microservices strategy to break your big problem into small pieces. Then you use Docker to package each of those pieces up into a standard portable container. And finally, you use Kubernetes to orchestrate that entire fleet, which gives you a system that is resilient, scalable, and super agile. So we've gone from one single server to a global fleet. We've seen how these 3 powerful ideas all build on top of each other to create systems that can handle just about anything you can throw at them. This is the toolkit that built our modern digital world. So the only real question left is, what are you going to build with it?